People planning to run a Telegram proxy almost always ask the same two questions. How much bandwidth does it actually use? And how many people can one server carry before it falls over? And the honest answer surprises them, because the part everyone worries about, the endless stream of messages, is the cheapest part by far. And the parts nobody thinks about are the ones that really size the box. Get this wrong in one direction and you pay every month for a server 10 times bigger than you need. Get it wrong in the other and your proxy chokes at the exact moment people are relying on it. So let me walk through where the bytes really go, what actually limits a proxy, and how to size one honestly. I run managed Telegram hosting on dedicated hardware here in Singapore. So provisioning is not a thought experiment for me, it is literally the job. I have watched real proxies and real hosted accounts under real load day after day, and I know from the meters, not from a forum guess, where the traffic concentrates and which resource gives out first. Almost every beginner sizes for the wrong thing, so this is the correction I wish someone had handed me early. Here is the plan: what Telegram traffic is actually made of, and why text is trivial, what a single user really costs you in a day, why voice and video calls are the spike that matters. Then the twist, that raw bandwidth is rarely the wall you hit first, and what the real ceilings are instead. The difference between running a proxy and hosting a full account, because they size completely differently. And finally, how to plan headroom and know when you have outgrown a box. By the end, you will be able to size a Telegram setup on evidence instead of fear. Found people fonts the traffic is actually made of, because that is where the intuition goes wrong. A plain text message on Telegram is tiny, a few kilobytes at most, often less. You could send thousands of them in a day and barely move the needle on a modern connection. The heavy traffic is everything that is not text: photos, videos, voice notes, documents, and the media that flows through busy channels. That is where the megabytes live, and a single forwarded video can outweigh a month of someone's typing. So think about a single ordinary user across a normal day. If they mostly type, send the odd photo, and read a few channels, they might move only a few tens of megabytes in total. That is nothing. The users who actually cost you are the media-heavy ones, the person downloading large files, the account sitting in busy channels pulling down video all day, the one backing up a huge chat history. Your average is set by a small number of heavy users, not by the quiet majority, so never size on the typical person alone. Now, the real spike, which is voice and video calls. A voice call moves a steady stream of audio the whole time it is connected, and a video call moves far more continuously for every minute it runs. One long video call can shift more data than a whole day of messaging, and a group video call multiplies that again across every person on the line. So if your users make a lot of calls through the connection, that single behavior can dominate your entire bandwidth picture. And it is the number you have to plan around rather than the message count you were worried about. Put that together into a rough per user figure. A light user, mostly text and a little media, might cost you somewhere in the low tens of megabytes a day. A heavy user, lots of media and regular video calls can easily run into hundreds of megabytes a day, sometimes more. That is a wide range on purpose, because the mix matters far more than the head count. 10 quiet users can be lighter than one person who lives on video calls, and any sizing that ignores that will be wrong. Here is the twist that changes how you size everything. On a normal server with a normal connection, raw bandwidth is almost never the first wall you hit. A cheap modern box already has more throughput than a few dozen chatty users will ever saturate. What actually gives out first is something quieter: the number of connections held open at once, the little bit of processor work each of those connections costs, and above all, the health of the IP they all sit behind. Bandwidth is the thing people measure and rarely the thing that breaks. Take concurrent connections first. Every device using your proxy holds a live connection open the whole time it is online, whether or not anything is being sent. An mtproto proxy handles many of these at once, but there is always a ceiling set by memory and by the operating system's limits on open sockets. So the number that matters is not how many users you have registered, it is how many are connected at the same moment at your busy peak. Size for the peak of simultaneous connections because that is what fills the box. Then there is the processor cost. An mtproto proxy wraps every byte in an obfuscation layer, the very thing that makes the traffic hard to detect and block. And that wrapping costs a small amount of CPU for each byte that passes. On a tiny server carrying tens of users, this is nothing you will notice. It only starts to matter at hundreds of active users pushing media at once, when the constant wrapping and unwrapping adds up. For most people, the processor has plenty of room, but it is worth knowing it is there. Now, the distinction that most sizing guides completely miss. A proxy and a hosted account are two entirely different jobs with entirely different costs. An mtproto proxy only relays traffic. It never logs into anyone's account. It just passes obfuscated bytes back and forth, so its cost is mostly connections and throughput. Hosting a full account is heavier because something has to actually be logged in and running, a real client on a real device or handset, keeping a session alive around the clock. Do not size those two as if they were the same, because a box that relays for 100 people may only comfortably host a handful of live accounts. And understand that idle is not free. Even an account doing absolutely nothing, sitting silent, still holds its connection open and still sends a small heartbeat to stay online and receive messages. So a stack of quiet accounts is not weightless. Each one costs you a socket and a little memory just to stay reachable. When you plan for many hosted accounts, you are planning for the always-on baseline of all of them together, long before anyone sends a single message. But here is the resource that is genuinely scarce, and it is not bandwidth, processor, or memory. It is the IP itself. One clean address can only sit under so many accounts before the density starts to look like a farm rather than a person. And that pattern is exactly what gets an IP distrusted. Bandwidth is cheap, and you can always buy more. A clean, trusted IP that many accounts can quietly leave behind without drawing suspicion is the hard part. And it is the real limit on how much you can safely pack onto one connection. So how do you actually plan this? You measure, you do not guess. Start with a modest box, put your real users or accounts on it, and watch it for a week under genuine use. Look at the peak number of connections at once, the peak throughput, and how the processor and memory behave when everyone is active together. Real numbers from your own traffic beat any rule of thumb, because your mix of light and heavy users is unique, and it is the peak, not the gentle average, that decides whether the setup holds. Then size for that peak with generous headroom on top. A good habit is to run comfortably below the ceiling even at your busiest, so that half your capacity is still spare when everything is flat out. That sounds wasteful until the day something spikes. A big event, a flood of media, everyone piling onto calls at once, and the box that was already maxed simply falls over. Headroom is not waste. It is the margin that keeps the proxy standing on the one day it actually matters. You will also want to recognize the signs that you have outgrown a box before it collapses. Latency creeping up when the server is busy, calls that turn choppy or drop at peak times, media that stalls partway through a download, connections that reset when load is high. None of those are random glitches. They are a server telling you it is running out of room, and the answer is not to keep cramming more onto the same address and hope. Catch those signals early while there is still slack, because a proxy that fails under peak load fails for everyone at once, which is the worst possible moment to discover you were too optimistic, because scaling a Telegram setup is horizontal, not vertical. More users does not mean one giant pipe on one heroic server. It means more clean IPs and spreading your accounts across them so that no single address ever carries a suspicious density. You grow by adding clean connections and balancing load over them, not by stacking everyone behind one overworked IP. That is true whether you run proxies or host accounts, and it is the opposite of what people instinctively reach for. Let me be clear about scope, because it matters. Everything here is about sizing an honest setup, a proxy or a set of hosted accounts, so that real people get a stable, reliable connection. It is not about seeing how many throwaway accounts you can cram behind a single address, which is precisely the dense machine-like pattern that gets an IP flag and everyone behind it punished together. Good capacity planning is the careful version, the one that keeps every account healthy rather than the one that burns them in a batch. And here is the honest catch, the same one that runs under all of this. Measuring real load, sizing boxes to the peak, keeping headroom for the bad day, spreading accounts across clean IPs so none of them looks like a farm, and keeping every one of those connections stable and online is steady, fiddly, ongoing work, and it only gets harder the more accounts you keep alive. That unglamorous provisioning, the part that actually decides whether your setup stays fast and trusted or slowly falls apart, is exactly what managed hosting is built to carry. Telegram Vault is managed Telegram hosting on dedicated Singapore hardware, real handsets on real carrier SIMs from Singtel, M1, StarHub, and Vivify. So your accounts sit on clean, stable mobile IPs with real room to breathe, sized and provisioned properly, kept continuously online, instead of crammed onto one overloaded connection that falls over at the worst moment. If that is what you need, start at telegramvault.org. Onboarding begins with a real conversation about your setup, not a checkout page, and the code TGYT gets you a discount when you start. If this changed how you think about sizing a Telegram proxy, from guessing at bandwidth to planning for peaks, connections, and clean IPs, then subscribe, because there is a lot more on running Telegram accounts and infrastructure cleanly coming on this channel. Thanks for watching, and I will see you in the next one.